Good day everyone. I am Mrs. Brinda, Assistant Professor from the Department of Civil Engineering at Kamaraj College of Engineering and Technology. I welcome you all for the presentation on design of flat slabs using STAAD Pro. We have dealt in the previous lecture series about the basic comments and the working principles of STAAD Pro along with the working procedure. Let us have a clear introduction about flat slab. What is what? So, flat slab is a reinforced concrete structure which transfers load, works similar to two-way slab but transfers load along both x and y directions. The key difference between two-way slab or one-way slab with the flat slab is supported only on column, not upon beams. There are fewer types of flat slab, including flat slabs with drops, flat slabs with captive column head, flat slabs with column head, flat slabs with column head and drop. Let us see the basic analysis model of a flat slab without drop. As soon as the information panel is open, you should provide the file name and we should give the location as we did in the previous STAAD Pro models. So, the panel should be in the selected mode with analytical model. You should create a new job. After getting into the proper location and setting units, we shall proceed with creation of new model. So, now the working space is ready. We should first provide the grids. We have 3 more grid panels. If you don't want, we shall remove it, but using grid it will be useful. So, it is a linear grid. We should provide the details or nodes along x as well as z direction as denoted in the coordinate axis. As you know, flat slabs are slabs which are designed without any beams. You should provide the longitudinal and longer and shorter directions of the slab. We shall provide along the longer direction a length of 5 meter and along the shorter direction a length of 4 meter. So, after the model is ready, now we shall proceed with, now we should enter, we have created a panel with 5 meters by 4 meters. If you press escape, the grid will go away. Now, 4 beams to be created under 4 nodes. We can select these 2 nodes along Z direction and we can type Ctrl V for paste option. Along Z direction, the offset will be 0.5 meters. Along x direction, the option will be 0.5 meters. So, I am repeating the same. As the nodes to be created within the panel we have created earlier, we should give minus. So, now our structure is ready. The same way we shall proceed along the Z direction too. You can see the offsets of nodes along the corners we have created both along x and Z directions. Now, the entire segment to be added as a plate, then only we can analyze it as a slab. So, I am going for add plate option. Now, we have covered all the 4 corners. Now, let us get into, select the entire structure. Now, right click, we shall move the selected entities along y direction also. So, we shall give thickness of 15 centimeters. So, likewise along the downward direction it should be minus Now again add plate, make all the entities into a single surface. Again we should go with parallel to y-axis option. Use node cursor. We shall select all the nodes and the views can be changed accordingly. And selecting translation, repeat. Now the entire setup to be repeated for 3 meters downwards along y direction. Now your frame along with the flat slab is ready. You can see the entire frame containing the flat slab. Now we shall assign the property. So we shall give depth as 0.4 meter and width as 0.3 meter. Again go to parallel option. Now we should give thickness to the slab. The entire slab thickness will be 0.15 meter. So it's time to assign the properties to the slab. You shall provide depth as 0.4 meter and width as 0.3 meter, selecting the concrete as material. And we should assign the thickness to parallel to XZ direction. Now give the value as 0.1 meter uniformly throughout the slab. Now assign the thickness parallel to XZ direction. Now the thickness has been uniformly distributed. You can see the assigned nature of your slab. It has the thickness spread uniformly along the 4 columns. You can see the 3D view. You just click the rendered view. You can view the thickness along with the entire structure. Now we shall provide the load details. First click the load case. You add the dead load. Again you should provide live load also. So click on the live load and add, again close. Now you should assign self weight. You should feed the value. Now select self weight. It is already in selection. The factor is -1 along y direction. Give live load also. Select plate loads pressure on full plate. Give -2 kilonewton per meter square along global y direction. As it is a slab, you just assign all the values to the entire slab, including self weight as well as the live load. Now provide the live load for assigning into your slab. Select plate cursor and select parallel to y direction. Now click on assign to selected plates, then your live load will also get transferred and assigned successfully. After completing the loading, you shall provide the supports. The supports as it is in the default mode, you shall give as fixed support. Now you just click the view to front view, then only your columns shall be assigned in a single click. Now again go to the 3D view. It's time to analyze. You provide analysis print option, then give run. The analysis is going on. It's taking little bit. So our output has 0 errors and 33 warnings. Now your structure is ready with the entire analysis setup. As there are no warnings, we shall proceed with design also. Select the entire structure, go to translation, repeat along Z direction. With a spacing of 4 meter, with number of steps or floors as 1. Now you can see another bay has been opened with the similar entities. So don't forget to give link steps. Now 4 panels has been created. Again you shall give a default spacing of 3 meter, that is floor height, with we shall select 2 floors. Now a building with G+2 floors is ready. This is a frame without any beams. Usually frame consists of beams and columns along with slabs. This particular frame has only column as well as slab unit devoid of beams. Again you should give support. Check the front view for easy assigning. You select the nodes at the ground floor. There are 9 number of nodes being selected. You just assign the fixed support. Now again give analysis, and now run analysis. The structure is being analyzed. It will take a while. So I don't need the output file, so I am staying in the modeling mode. If you need the output file, you just take the if you are intended to take the printout, you just take the output file copy. Now you just select the parameters for concrete designing. Whichever parameters you need, you just click the right arrow, single arrowhead, that is FC, F main, FY main and FY second, that is FY main reinforcement and F secondary reinforcement. We just provide the details here, that is compressive strength of concrete. I have assumed M25 grade concrete, and FY main, the yield strength for main reinforcement is 415,000 kilonewton per meter square, and again add the same detailing for secondary reinforcement too. I am going with 415 FE 415 grade steel only, both for main and secondary reinforcement. Now add design commands. Select design column and add, design slab and element add. Now don't forget to add takeoff. Almost the design parameters are set up. So now add all the parameters. Make sure your assignment method is assigned to view. So entire frame should be assigned with all these reinforcement details as well as details. So you just align for columns. The design column you should assign only for column. You better select the parallel option, then the horizontal beams as well as vertical columns can be assigned separately as per the design commands. Now again you go to analysis, run analysis, save, and now the design is being processed. It's done. Your structure is ready after analysis and design. Now apply load case. You can check the bending moment, displacements, reactions for beam, column as well as plates. You just click on the diagrams, select the plate stress contour. You can get the maximum, minimum and safer values of stresses being applied on each floor. You can change the color codings also. I am intended to get the animation of the structure for the entire structure. So you can see the difference. Now go to analytical modeling, the 3D rendering view. You can check the dimensions we have fed and the entire 3D view of the frame along with columns as well as your flat slab. We have done the analysis and design part for flat slab. We have done the analysis of two-way slab as well as one-way slab, as the structure is a special one because as the structure is a space saver for interior designing purpose, as well as the structure gives flexibility when compared to one-way slab and two-way slabs. So, for the flexibility and space concerns, we shall proceed with the design of flat slabs. Hope you have understood the basic concepts. Hope you have seen the basic concepts how to design a flat slab after analysis using STAAD Pro software. Thank you.